Hi guys, today I am going to talk to you about dissociation equations. So you will need your notes, you'll need a highlighter and a pen to write with. Okay? All right, let's get started. So another type of separation is actually called dissociation of ions in water. What that actually means is that the word dissociation means to break apart. And the word ions actually means plus and minus charge. So if we're talking about this, you have two types of charges. You have something called a cation, and you can remember cation because that T is actually a plus charge, and then an anion, which is a negative charge. These are the two types of charges. Okay. So there are two types of charges right here, positive and negative. And of course, when we talk about water, we are actually talking about H2O. And the H2O actually looks like this. This is the structure for it. The oxygen also has ions. It has the water also has ions. The oxygen is negative charge and the hydrogens are a positive charge. Okay? So salt, which most of you know, the typical salt is table salt, NaCl, that you use at home. But there are many different types of salt out there, and every single salt has the exact same pattern. The first element is always positive, and then the second element is always negative. So the salt can be recovered by evaporation of the solvent, which is of course water here. So what does this really mean? So keep in mind, ionic substance is positive and negative. The ionic substance dissolves in water and you end up producing ions in the process. So let's look at this equation right here. You will be responsible for writing a dissociation equation just like this. Okay? So if you have sodium chloride, remember this is a salt. This is really table salt that you have at home. There are many different types of salt. Keep that in mind. And of course, sodium will be positive, going along with the positive first. So sodium is positive, and then chlorine will be negative. So this will be negative. Okay? So that's sodium chloride right here. And what happens is that your table salt that you have at home is a solid. Okay? And keep in mind that if you have the state of matter is always written as a subscript, and S stands for solid, the L stands for liquid, the G stands for gas, and then we have something new called aqueous. AQ stands for aqueous. So the word aqueous actually means mixed in water. Okay, that's what it means. So you've got sodium chloride, that's a solid. And what happens is that this sodium chloride, when it is mixed in water or put in a beaker that has water, the water actually comes, so you have H2O right here, and it actually ends up breaking the sodium and the chlorine from one another. So it literally pulls it apart. It pulls these two apart. So, and that's what we're actually saying right here. Remember, this water is a liquid. So that's what's going on here when we talk about it. Let me get a different color out to show you. Okay, that's what we're talking about right here, that this is what's really happening. The sodium chloride breaks apart and forms into these pictures right here. So you have sodium that is all by itself. Remember, it has a positive charge, the sodium, and now the sodium is going to be attracted to, when we're looking at water, Since it is positive, it's going to be attracted to the negative oxygens. That's why you see the oxygens bonded here. So this is a negative that it's bonded to. Keep in mind the hydrogens are always positive. So the sodium bonds with the negative oxygen, and that's why you have the word aqueous, because it is surrounded by water. So this is what happens to sodium. This is how we write it. We write it like this. The chlorine, on the other hand, this is what happens to chlorine, and we write it like this. Okay. So the chlorine, remember, has a negative charge, so you have chlorine that's negative. And now as far as water goes, it's not going to be attracted to the negative of oxygen. Rather, it's going to be attracted to the positive of hydrogen. So you've got the negative chlorine that's attracted to the positive hydrogens right here, not the negative oxygens. Okay, so you've got chlorine that is mixed in water, and that's why it is aqueous. Okay, so these three pictures actually illustrate this chemical equation. You have sodium chloride, that's a solid, mixes in with liquid water, and then the sodium and the chlorine are pulled apart, and the sodium will be attracted to the negative part of oxygen, and the chlorine will be attracted to the positive part of oxygen. Now keep in mind, you guys, that the dissociation is a type of a physical change, because you're just taking salt and you're just dissolving it in water. So the salt does not change. What ends up happening is that once you evaporate the water, now the sodium and the chlorine, they are going to be attracted to each other again. So the sodium and the chlorine will be attracted to each other again, and they're going to form a bond. Okay, that's what happens once the water disappears or it evaporates. When the water is there, the sodium and the chlorine will be separate, because each one of them is going to be surrounded by water separately. So that's why salt doesn't change into a new substance, even though it's dissolving, because when it dissolves, it's just simply being surrounded by water temporarily. It will, once you evaporate the water, you get salt again. Okay, so that's really what's happening with the dissociation equation. So we have three practice problems, and keep in mind salt is positive and negative. Okay, so many different types of salts. Here are three different types of salts that we have. The first one is iron and chlorine. So, and all salts always have the same pattern, positive first, and then the second element is negative. So in this case, you have iron that is positive, and you have chlorine that will be negative. Okay, keep in mind they're both solids. This compound right here is a solid. Okay, when it is mixed with water, and the state of matter for water is liquid, it will then, iron will break away. Iron has a positive charge, but this iron will be surrounded, just like the sodium, with water. So we're going to say it's aqueous. And then the chlorine is going to have a negative charge. Again, this chlorine is now going to be surrounded by water right here. So we say it is aqueous. Okay. Now, one thing that you could probably notice is this number right here. This 3. Well, this 3 means that there are 3 chlorine atoms. So we're simply going to come back and put a 3 right there. Okay? Let's do one more. Sodium sulfide. Sodium, the Na is positive. The sulfur is negative. Keep in mind that they're both solids. At room temperature, it is a solid. You have liquid water that comes, remember, liquid water comes and breaks this up. And when it does, this becomes sodium that is positive, but it's surrounded by water. okay, each time. So we're going to write AQ. And then you have sulfur, which is negative, is also surrounded by water. That's why we put AQ. Now keep in mind that this sodium, there is a 2. So we're going to go back and put this 2 right in front of sodium. Okay? Go ahead and try the third one yourself, and then look up once you are finished. Okay, go ahead and look up. The last one is, just check your work, but the last one is lithium phosphide. Lithium is positive, phosphide is negative, and remember it is a solid. All your salts are always going to be solid. They mix in with liquid water, so this is always going to be a liquid, and they will produce lithium, which comes first, so it's going to have a positive charge, and because lithium is positive, it is going to be surrounded by water because this is a salt, and so it's going to be surrounded by water, so we're going to say it's aqueous. The phosphorus is also going to break up from lithium, and now it's going to be surrounded by water. So we say phosphorus negative AQ as a state of matter. Keep in mind that we have lithium has a 3 in front of it, so we're going to put a 3 in front of lithium. Okay? So I hope this helps you understand what dissociation equations are. They are a type of a separation technique. It's what happens when you filter. Earlier when I talked about this, when you were filtering, the substance has in here sand, salt, and water. So when you filter this and put it in here, what happens is that your sand will remain behind or in here, and what's going to happen is that you are going to have salt water. So what's happening to the salt water in here? Well, it dissociates. The salt you can't really see because the salt is now mixed in with water. So in the salt water, the dissociation of ions in water is what is happening. Okay? So this is how your salt looks in water right here. So I hope this helps you understand what is going on, and I will talk to you guys later. Bye.